All right. Good morning, folks. Hope welcome back. I want to go ahead and pick up with where we left off yesterday, and that was with the discussion of these mole ratios. And so we talked about and we defined the mole ratio as a fraction, a ratio that compares two parts of a. I'm sorry. Let me go ahead and go back up here. Sorry. Yep, and so we wanted to take these mole ratios, and so these mole ratios basically compare two parts of a chemical reaction, and we are comparing the moles, the number of moles of a particular reaction. Okay, so we take two parts. So just pick two of the components of the reaction, and we make these mole ratios, and we can use these mole ratios to calculate for the ratios if we change. Okay, so we change the quantities, and we don't have the ratios that the quantities that are stated in the balanced equation. So we can go ahead and use the mole ratios then to calculate for what would happen if we change one part of the reaction. What would happen to other parts of the reaction as well? So these mole ratios that we use here. Okay, let's start out with this as a quick review. Okay, so these mole ratios that we use, these mole ratios are basically again this two parts of the reaction. We take two parts of the reaction and we're comparing the molar quantity of those two parts. And so when we do that, these mole ratios end up being, they tell us then the equal amounts, they are the equivalent amounts of the two parts of the reactions themselves, itself. Okay? And so we can use this then as a conversion factor. The mole ratios here, the reason why we want to identify these mole ratios is that we want to be able to use them as conversion factors. Okay, so these will be the conversion factors that we will use to do conversion between two parts of a reaction. So we left off with this particular problem yesterday, when I asked you to go ahead and work out this problem here. I asked you first and foremost to identify all of the mole ratios that you can obtain from this particular reaction, and then choose the correct mole ratio in order to calculate for this problem, and that is to do the conversion. So let's go ahead then and let's work out this problem. So pause the video, okay, and go get your work from this work here from yesterday. Okay, so go make sure you get that. Okay, and then what we want to do then is I want to go over this with you, and then I want to continue practicing more of these problems with you. Okay, so at this point here, pause the video, go get your work from yesterday, and then we will get started with this problem. Okay. All right. Let's go ahead then. Now that you have your work, let's go ahead and let's take a look at what we have here. So what I'm going to do first is I'm going to go ahead and rewrite the equation here at the top for us so we can have it. Okay. So this is going to be the reaction between aluminum. We have then and oxygen. Okay. To produce for us then aluminum oxide. Okay, and so the balanced equation then is in a 4:3:2 ratio. Okay, and so if we were, so that means then we need to start out with then 4 moles of aluminum. We're going to react it with 3 moles of oxygen. If we do that, we will form 2 moles of aluminum oxide. Okay, so therefore the mole ratios that we can obtain from this one is going to be then the first comparison we can do. Then let's go ahead and compare the moles of aluminum to the moles of oxygen. Okay, so this is the first equivalence that we can establish from the balance equation. So therefore, the 2 mole ratios that we can obtain from this then is going to be 4 moles of Al over 3 moles of O2. Take the reciprocal of that then, it's going to be 3 moles of O2, 4 moles of Al. And we said then that those two will be equal because of this equality here. So that's the first set of mole ratios that we can obtain. Whether we use this or not will depend on the problem. Okay, but let's go ahead and let's continue on with identifying the mole ratios. So we have aluminum and oxygen. Let's do aluminum and aluminum oxide. So that means then for every 4 moles of aluminum, that's exactly equal to 2 moles of aluminum oxide. Okay, again, these numbers are taken directly from the balance equation, and from this equality here, we can write 2 more mole ratios. Okay, and the first one being then 4 moles of aluminum over 2 moles of aluminum oxide. Take the reciprocal of this, that'll be then 2 moles of aluminum oxide, and 4 moles of aluminum. And again, these two ratios, those two fractions, will also be exactly equal to one another. Okay. All right, let's do the last one. Okay, so we've done aluminum and oxygen. We've done aluminum and aluminum oxide. The last one, the last two that we can compare then is going to be the last one that we can do then is oxygen to aluminum oxide. Therefore, there will be 3 moles of oxygen, exactly equal to 2 moles of aluminum oxide. Okay, and let's go ahead and write out the two ratios, the two fractions for this one. That'll be then 3 moles of oxygen over 2 moles of aluminum oxide. Take the reciprocal of those of that fraction, 2 moles of aluminum oxide over 3 moles of oxygen. And again, those two equal to one another. Now, as you move forward with these problems here, folks, you do not have to write all of these out. You just have to make sure you pick the correct one. Again, you don't even have to write out all these. You have to just make sure you pick which one of these 6 that you would need in order to solve for the problem. Okay, so let's go ahead then. Let's solve for the problem. Okay, let's solve for the problem and let's work this one out together. Because the problem asks, and so it's a conversion now. Now, what we've done is we've listed all of the possible conversion factors. Again, we will not use all of them. We for this problem, we're only going to use one of those 6. Okay, so you just have to make sure then. Again, early on here at the very beginning of this of going over this, I would suggest you write it all out. But at some point, I think as you do the homework for tonight, so set B is due tonight, so I'm going to assign set C for you. But as you do this, you're going to realize then that you don't have to write all these out, that you can look at the balanced equation here and decide what mole ratio you will use. Okay, so for right now, if you need to, write it all out, go ahead and do so. But let's go ahead then and let's solve for this problem, okay, because the conversion here doesn't deal with 4 moles of aluminum, 3 moles of oxygen, or 2 moles of aluminum oxide. If you saw then, what they ask you then, what they give you, what you start out with then is 3.7 moles of aluminum oxide. They are saying then that if this is the amount of aluminum oxide that forms, that's the amount that is given to you. Okay, the question then is, okay, how much aluminum did you start out with? Okay, that is then they want you to find the mole of aluminum equivalent to 3.7 moles of aluminum oxide. So what they give you is the amount of aluminum oxide. What they're asking you to solve for is the amount of aluminum. And the amount is going to be in moles. And so therefore, the conversion then, folks, is from moles of aluminum oxide to moles of aluminum. So let's go ahead and pick which one of these 6 will we plug in here. Well, if we take a look at the very first one, the first one has aluminum in it, but it's aluminum and oxygen. Okay, so this is not going to work for us. Neither one of these two will work for us. Okay, let's take a look at the last one here. Okay, the last one here compares oxygen to aluminum oxide. Okay, and so that won't work for us either. And so it has to be one of these two that we're going to use. One of these two that we're going to use in order to solve for this one. Okay, because in both of these here we have aluminum and we have aluminum oxide. Now we just have to make sure we figure out which one we're going to use. Okay, so with that said, then hopefully everyone sees then that this is we're going to use one of these two. So which one of those two will we use? Hopefully you recognize that it's going to be this one right here, and the reason why, okay? Because we want to be able to, when we plug it in, we have 4 moles of aluminum here, okay, and 2 moles of aluminum oxide here in the denominator. And the reason why we choose that one is because then we are allowed to cancel out that unit of aluminum oxide, and we end up with moles of aluminum in the numerator on both sides. Okay? So at this point then, we can go ahead and plug in our numbers, okay? So basically double the amount of aluminum oxide, and we end up with 7.4 moles of aluminum. And that, folks, is our answer. Doing these problems, folks, end up being very simple. Now, again, did you have to write out all 6 to come up with this? No. What you do then is you see then that this is what you start out with. You start out with aluminum oxide. This is the given. They want you to find aluminum. So you go up here and you just find the coefficient for aluminum. You find the coefficient for aluminum oxide, and then you just plug it in so that the aluminum oxide cancels out. And the moles of aluminum is what you end up with. So again, you will come up with this exact mole ratio here without having to write out all of these here. Okay. So what I would like you to do is, so practice that, folks. To practice that, make sure you get that. So what I would like to do then is let's work through a few more problems here that involves conversions here, and you'll get the hang of this. Okay. All right. So let's so practice that. Okay, and then come by and see me after school if you have any questions on this. But we do have to continue on and talk about what we can do with this type of conversion. Because understand this, moles, doing the moles to moles calculation, I think that's pretty straightforward. I don't think that's going to be an issue here. But the question that we have, the issue that we have then is, make sure you keep this in mind, I've mentioned this quite a bit, we don't have any means to measure out quantities in moles. Okay, so that means then the moles are not an efficient unit. They're not an efficient unit for us to do to measure out in real life situations. We don't have a beaker. We don't have a graduated cylinder. We don't have a tool, a measuring device that we can use to measure out moles. And so what we have to do is we're going to carry out these reactants here. We have to be able to measure out these quantities in either masses or in terms of volume. Okay, so that's what we have to be able to do. And so what we're going to do here first is we're going to talk about how we can change and convert into masses. So the first stoichiometric calculation we did was a mole to mole calculation. And remember, stoichiometry is basically just taking the balanced chemical equation and trying to find out quantities and trying to figure out quantities involved in that particular chemical reaction. And so here then, we did the first stoichiometric calculation. The quantities we used were moles, but then like I pointed out to you here, moles is not exactly the best way to go about measuring out quantities. And so the second stoichiometric calculation we're going to do is the mass calculation. Okay, and the key here then is what we need then is we're gonna need to remind ourselves about these molar masses here. Okay, and so we're going to use the mole ratio. We need the mole ratio, and we need these molar masses here. And remember, the molar mass, as we defined it, the molar mass is the, and let's go ahead and write this down here. The molar mass is the ratio of grams to moles. Okay, so this is the ratio that we're going to use here to grams per mole, and we're going to use that as part of our conversion as well. Okay, so these conversions here are a little bit more involved, okay, but they're not that much more difficult. Okay, so let's go ahead and let's take a look at what we have. Okay, so in order to, the goal here is if we have the mass of one of the components of the reactant. Let's say we have the mass of one reactant, okay, and we want to find, if we know that mass, we wanted to find out how much product we're going to get in the reaction. So we're comparing two different masses here in the reaction. We start out, we know the mass of a reactant, and we want to find out how much product we're going to get, the mass of the product that we will produce if we have a certain amount of reactant to start out with. Now, in the course of this process here, we can't get to that directly. You cannot solve for that directly. There is no conversion factor here. If this is the conversion that we want to do, there is not a conversion factor that we can plug in here to get that done. However, we just did this. Again, if we know the moles of the first of the reactant and we want to find the moles of the product, we can do that because we have what's called the mole ratio. So this, remember, this mole ratio here is what we get directly from the balance equation. The balance equations, the numbers, the coefficients from the balance equations will not get us, we can't plug that in to get from mass 1 to mass 2. But if we know what the moles of compound 1 is, and if we want to find the moles of compound 2, we can do that because the coefficients give us the mole ratio. That's what we just did. Now the problem is this. Folks. We need to get to moles. We are given mass here. Can we get from the mass, the given mass here, to the moles of compound 1? Well, this involves a mass to mole conversion. Now think back to what we did in chapter 10. Is there a conversion factor that will get us from mass to moles? Absolutely. It's the molar mass. Okay? The molar mass here then will get us from mass to moles. And so what you need to make sure you keep in mind then is that for this very first one, you're going to use the molar mass, but I would suggest you write this in, but we're going to take the molar mass and we're going to divide. Okay. We're going to use the molar mass. We're going to divide mass 1 by the molar mass here. And there it is. Now then that we have the moles of compound 1, after this conversion, we can go ahead and do the second conversion. So this is the first conversion in a series here. So to get from mass 1 to mass 2, to do that calculation, to do that conversion, this is going to be a 3-step conversion. Okay, so this is the first step then is involving the molar mass. And we can divide by the molar mass to get the moles. The second conversion here, the second conversion, will involve the mole ratio. Okay, so it involves the mole ratio. Okay, and we'll get to moles here. Okay, all right, so 2 conversions so far, we get to this point. We get to this point here. Now, the question is not about moles here. Okay, so we still need to measure out. We need to weigh out how much product we're going to get. At the end of this second conversion here, we're only at moles. And so the question then is, once we get here, can we get from, if we know what the moles of compound 2 is, can we get the mass of compound 2? And again, the answer there will be yes, because we can use the molar mass of compound 2. And in this case, then what we're going to do is we're going to multiply by the molar mass, and this will represent the third calculation, the third conversion in this here. So we want to do, this is the main conversion that we want to do. That's the goal, folks. That's what we want to do. But to do that conversion, we have to do 3 separate conversions here. 3 separate conversions here. Now, what I'm going to do then is, instead of doing 3 separate conversions, we know then if we're going to do 3 separate conversions, we need 3 conversion factors. And so instead of doing 3 separate conversions, let's just go ahead and identify all 3 conversion factors that we need and plug it into one long conversion problem. Okay, and that's how we're going to approach this. That's how we're going to approach this. I'm going to work these problems out for you. We're going to work these problems out together. Okay, and then that way, then you just have to practice. The method in which we're going to do this, the method in which we're going to do this is going to be exactly the same. You learn it the first few times, and then afterwards, it becomes very straightforward and very methodical. Okay? So let's go ahead then, and let's take a look at a sample problem here that we want to do. Okay, so let's go ahead and take a look at the sample problem. Let's take a look at this one here. Okay. All right, so first of all, let's read what we have here, and let's identify what we need to, what we're given and what we're solving for. Okay. So they want us to find here, they calculate the number of grams of ammonia. So they want us to find this. So this is what we want to end up with. So in our conversion here, this is what we want to end up with. Okay, so this is the end amount. Okay, so we want to find the grams of ammonia. Okay, okay. We are given this amount here, grams of hydrogen. So that is what is given. So this is what we start out with. Okay, so that's a start. Okay. Don't worry. So let me come back to this, what this means in just a moment. Okay. And so with that said, then that's our conversion. Okay? The conversion here is between hydrogen and ammonia. But this is a chemical reaction. So the very first thing we always have to start out with then is the balanced equation. Okay, let's go ahead and let's start out with the balanced equation. And so make sure you have this here. Okay, and I'm going to go ahead and I'm going to get a screen that's going to help us here. Okay, so let me go ahead and clear this out. Okay, so let's go ahead then. We need the balanced equation first. Okay, so this is a reaction that involves the formation of ammonia. Okay, so calculate the number of grams. The balanced equation was given earlier. Okay, so the balanced equation, remember, well, then was the reaction between nitrogen plus hydrogen to produce ammonia. So that's the reaction itself. Okay, so with that said, then the balanced equation here then is going to be 1, 3, 2. So the balanced equation then is 1 nitrogen, 3 hydrogens, and 2 ammonias here. Okay, so that was from the previous. We've been using this reaction for quite a bit. Okay, all right. So what I typically do then, so once you have the balanced equation, make sure you always get the balanced equation first. What I would do then is I would actually write down what they give us. Okay, write down what is given to you. Okay, so what they tell us here then is that we start out then with 5.40 grams of 5.40 grams of hydrogen. This is what we're given. They want us to solve for that. That's what we want to end up with. And then they say that this is in excess. Okay. What this means then is in excess means that you have more than enough of this. Now, this will come into play when we start talking about limiting reagents. Okay, so don't worry about this right now. Don't worry about this right now. The term here, excess, we'll talk about later, but for right now, what you need to understand is that we have more than enough of this. That way, then we can just focus on this. So the conversion then is this conversion right there. Okay, and they want us to solve for this in terms of grams. So this is a mass to mass conversion. Okay, all right. What I would like you to do, and I've run out of time here. Okay, so what I would like you to do is to help us with the discussion tomorrow. To help us with the discussion tomorrow, I would like you to write out the mole ratios. The mole ratios for this particular compound, for this reaction. So what I would like you to do for tomorrow, okay, for tomorrow, what I'd like you to do is, first and foremost, write down the mole ratios. What are the mole ratios? And again, at some point, you won't have to do this anymore, but since we're still working on this, I want you to do that. So find the mole ratios. Okay? I want you to find the molar mass of hydrogen, okay? And then I want you to find the molar mass of ammonia. So on your paper for today, and what you're going to submit today then are these three here. Find all the mole ratios, calculate for the molar mass of hydrogen, and calculate for the molar mass of ammonia. Because we're going to use all of these here. We're going to use them in order to do this mass, to do this conversion here. We will need these values here. So make sure you have that for tomorrow, but I do want you to write it in, write it out now, okay? And then submit it before the end of the period, okay? And then have it available for tomorrow, and we'll finish up working out this problem tomorrow, okay? All right, so very good, folks. Go ahead and get that done. If you have any questions, come on by after school today and we can work this one out together. If not, I will see you folks tomorrow, okay? Have a good day, folks.